there on the flight deck just prior to liftoff, and there's liftoff. You'll see the sun. Oh, there's liftoff right there. The first one was the engine starting up. You'll see the roll program here as the sun kind of shines through the cockpit. Right there, the orbiter is going through its roll maneuver, roll program, and the vehicle just flew beautifully. We had a great ride. We had brilliant sunshine coming in through the windows in the front, and it was just a fantastic ride all the way up. Some people have said that sometimes Columbia, they have to do a lot of work on it on the ground, but when it gets in space, it just does wonderful, and we think that's because she just loves to be in space.
The next segment shows the mid-deck. During the ascent, you can see Ilan, Ramon on the left side of the screen, and Laurel Clark in the middle, and Mike Anderson to the extreme right. And there was liftoff. And you can see all the shaking that happens in very fast sequence as soon as the orbiter launches.
As you can see down the lower left, there's Mike Anderson coming up from the middeck, preparing for the ET photo that we're going to do once we pitch the orbiter up. And Dave Brown, there on the right, is getting out of his seat and getting his seat prepared to take some video of the external tank. Mike's taking pictures with the F5 camera, and Dave there is getting his parachute out of his seat, kind of getting everything out of the way so that he can then fold his seat down and get in a position to be able to take pictures of the external tank. You see Willy and I are congratulating each other up front there, and we were very happy to welcome 4 new astronauts into the community with Willy McCool, Dave Brown, Laurel Clark, and Ilan Ramon. There you can see Dave getting all squared away and ready. Mike handed him the video recorder, and Mike comes on up into the cockpit to get himself into position to take those photos. You can see with the launch and entry suit on that it's a bit of a challenge coming up and maneuvering and everything, but they're able to get in position anyway. Dave's making sure he's got all of his settings correct on the camera here, and then getting ready to take a look outside the window and film that external tank. We've got some clips of the external tank coming up here shortly. There's a good shot of the external tank just shortly after we pitched up, and we're looking at it through the overhead windows of the orbiter, as you saw Dave and Mike getting ready to do earlier. And you can see every once in a while some ice particles that are floating across the screen. And here now with some of the contrast in the clouds, you get a sense of the kind of speed that we're going here after MECO. Meanwhile, inside the cockpit, Kalpana Chawla, MS-2, is busy helping myself and Willy get all of the checklist items done before we can get ourselves set up for the OMS-2 burn. And here you can see inside the cockpit, just prior to OMS-2 ignition, you'll see right there is where we got the ignition. And here in just a minute, I'll hold my cue card up and let go of it to give you an idea of the kind of acceleration that we're experiencing at that point. We're on the dark side of the Earth right here in the night portion of the path. There goes the cue card floating back. And we had an excellent OMS-2 burn. You can see the Earth kind of at the top of the screen there. We're looking to the left side of the orbiter when the radiator on the left payload bay door comes up. And as it starts to come up, you can see the reflection of the Earth in the radiator. And really pretty shot looking out the window there. And this is just kind of signifies all the great work that the ECOMs do for us, managing our heat loads and our water and the cooling here on the orbiter, which we very much appreciate. We've had a great flight and a great atmosphere up here, and it's just been a great working environment. We very much appreciate it.
This is a view of Space Hab kind of early in our flight. You can see myself, Kalpana, working on the zeolite crystal growth experiment, where we are growing material crystals in space. This particular experiment is from Northeastern University, from Center for Advanced Studies in Microgravity. And Laurel Clark is working on the bioreactor experiment. We are growing prostate cancer cells in the bioreactor. You can see Laurel working with the computer interface for the same experiment, trying to keep herself stable in the foot loop that we use on orbit. This study is being originated from Johnson Space Center, and the idea is to be able to grow bigger cells in space and thus be able to differentiate them better. Laurel is performing an analysis of the constituents of the media that is used to feed these cells. She will insert the cartridge that she has filled with the sample into the analyzer, and the analyzer will tell her what it contains. Mike Anderson in this view is working on the Advanced Respiratory System Ergometer. This particular study is being led from the European Space Agency. A number of studies being performed here where the crew members are working on various regimens of breathing protocols. The device on Mike Anderson's hand actually records, amongst other things, the blood pressure also. You can see Rick's husband here in Space Hab, the double research module. He's working on activating the water loop. He has removed one of the panel covers in the aft module. You can see the very impressive plumbing underneath this lab floor, while above the floor we seem to be working in peace with all these experiments. Underneath, a lot is happening in terms of systems.
Here's Mike Anderson, our payload commander, working on the combustion module 2. He was getting it configured for some tests later today. He's inserting a special module into this rack to do the laminar soot process experiment that's looking at the basic physics of flames and how to prevent more soot from coming off of them. Again, here we have Ilan, Ramon, working on MEDEX. He's looking at a computer and commanding some radiometric cameras outside in the payload bay that are measuring the reflection off of dust in the atmosphere. It has a huge impact on weather patterns across the planet. Ilan, as you probably know, is from Israel, and we're proud to have him here on this flight with us. He's been an invaluable member of the crew. We couldn't work on board without computers, and here you see one of the dozen or so that we have on board, and we interface with almost all the experiments with these computers. Of course, the computers can't do it all. Here's Ilan looking out the window real time to see where the dust storms are most significant so that he can direct the cameras to the right place. Here's Chawla, our American astronaut from India. She's working on an actual laminar soot process test that was done today. Ilan did one as well, and we're told the test came out wonderfully, and the investigators on the ground are thrilled with the results that they've gotten. Again, this experiment is looking at preventing any extra pollution and maximizing the efficiency of any number of types of different flames in engines or any other combustion process. Again, the PGSCs are invaluable. Well, this is me talking to the ground, discussing some changes in procedures for our bioreactor development system. We're growing cancer cells and bone cells together, looking at the signals that cancer cells send to bone cells. The tissues are doing wonderfully, but they wanted to make double sure that everything was going well, so the ground was telling me about some extra tests that they wanted to have done today. We performed those tests, and the tissues are growing well and metabolically very healthy. Here's Rick's husband, our commander. As you can see, being a commander entails a plethora of different activities. This is the mechanics of granular materials code, which is looking at the physics of sand and solids, shifting soils in earthquakes. We're having a little bit of less than optimal packing of the sand. So Rick is attempting to take a big clump out, and this gives a new meaning to packing sand up here in space.
This is KC, and she's working on an experiment known as BioPack, which is from the European Space Agency. And she's working in a glove box, which keeps all the little small parts of the experiment and any liquid from escaping from where she's working. This particular experiment, actually there's 8 experiments in BioPack. The one she's working on is called Bones and studies human bone cell cultures, and looks at the balance between calcium deposits formation and calcium absorption, trying to understand better how to prevent osteoporosis, not only the kind of bone loss that astronauts get in space, but something that might affect people that are at bed rest, or actually that everyone is at risk for on Earth, particularly women. Now, BioPack has a centrifuge, so things are exposed to microgravity, and then the centrifuge provides artificial gravity, and you can compare the two types of cell cultures. Next up for the blue shift was a blood draw back in the space hab. Here Laurel is, I think she's telling Mike at the moment that this isn't going to hurt her a bit. It turned out we're going to do the blood draws up against the stowage rack, so we decided to use the straps to help restrain the subject and also make sure that Mike can't make a quick getaway from Laurel. These blood draws are part of a set of experiments called Physiology and Biology 4, or Physiology and Biochemistry 4. And there's 4 sets of experiments: protein turnover, calcium kinetics, renal stone risk, and latent virus shedding. We've got quite a bit of stuff that we use for this, so we're provided with little clips of Velcro and the like to hold everything down. Of course, one thing about microgravity is instead of handing things, you can just pass them from one end of the module to the other. And so that's really handy sometimes, the lack of gravity. Part of the blood sample goes now to Ilan, and he's working with a portable clinical blood analyzer. And so we take these samples within 10 minutes of the blood draw and record them for the payload scientists. So not only do we store some of the samples, actually we store all of the samples, but we do some real-time analysis in the hab in space. We're kind of multitasking here in that we're using the combustion experiment as a workspace. So we kind of share all the space and all the payloads and take advantage of a spot when we can. Now this next clip, I'm going to step back to yesterday. This is Kalpana and Chawla working on the combustion module 2 experiment, and this was the very first burn of the laminar set processes experiment, sponsored by the Glenn Research Center, and in particular Dr. Jerry Faith, our good friend. Combustion Module 2 looks at a variety of issues that we face here on Earth. We burn things all over the world, people do, and this experiment looks at not only making combustion cleaner, but also how to make it more efficient. And one experiment even looks at how to extinguish fires, so sometimes things burn and we don't want them to. This particular one, again, it looks at soot, and if we can even make a small decrease in the amount of pollution from combustion worldwide, that's a major contribution. So here's the first ignition sequence of the flight. You'll see a light coming on in the chamber. Next, you'll see an igniter arm coming in. You'll see a good ignition. There's the flame. So here's the initial light off for combustion module 2 for STS-107. This flame is contained in a sealed cylinder. It's about 4 feet long by 3 feet in diameter, and we change out the hardware for each of the 3 major experiments in combustion module 2.
And now we're watching Laurel Clark in her BDS-05 bioreactor development system, which is actually prostate cancer research of the University of Virginia of Professor Ilan. And Laurel actually is transferring fixation to the cells right now. We need to work inside the Ziploc so that no spills are coming out. And this is the actual bioreactor. It's a little bit hard to see, but the cancer cells are growing inside there in a zero-G environment. Of course, the scientists have a lot of data and telemetry out of the bioreactor locker there. And here's the PJC that controls the bioreactor from our lab. And here is Ilan Ramon from Israel conducting the STAR experiment. This is a student educational experiment, and here we're looking at silkworms, and it's hard to see, but we have one that hatched actually, and it's a butterfly there, and the silkworms are from China. On this experiment we have actually 6 experiments. The silkworms come from China. We have a medaka fish from Japan. We have bees from Liechtenstein. We have the chemical garden from Israel. And we have spiders from Australia. And we have a space biosphere from the US. It's a great educational experiment. And it influences and inspires students all over the world. Here I'm trying to capture some of the web of the spiders from Australia. This is the inside of the STARS module. It's a little bit tough to see. And here's Rick, husband, our commander, in the brick experiment. The brick experiment is out of Ohio State University, and it tries to understand the orientational and distribution of the tips of some cells. Rick uses a special gun to
compensate the cells after some time. And here are the two guns in the hands of our commander, our great commander, Rick Husband. And back to Laurel, she is conducting the osteo experiment. We have two experiments on board, the osteo and the aristo. The osteo comes from Canada, the aristo from ESA, from Europe, and they both investigate bone cell loss, which is actually the cause of osteoporosis on Earth. There's Mike Anderson conducting a combustion chamber experiment, which is called softball. In 1944, a Russian mathematician came to a conclusion that flames in zero gravity, should have a ball shape. Later on, a follow-up, Professor Paul Roney from the University of South California discovered flames. And we're looking at Mike here, ignites three ball flames ball, and here is a close look of the balls of flames in space in our monitor. We up in space monitor and control the whole operation through a PSC, which is actually a laptop, and we have a lot of gas bottles, which you see on the right of the screen.
Here, Rick, our commander, is going up to the freezer that we have on board, and we're going to show you some of our liquid gold, our samples that we're collecting for physiology changes in space, urine and blood and saliva, and it's all being frozen, so we'll deliver it back home to the scientists who are eagerly awaiting.
Here's Dave Brown at the aft station working the MEDEX payload, where he's doing some observations looking for dust. We're looking for dust primarily in the area of the Mediterranean, and certainly we've got a great picture here of Egypt and the Sinai Peninsula, and up at the upper left part of the screen, Israel. We've zoomed into Israel here, where our world-famous astronaut Ilan Ramon is from. And he zooms in on this picture. You can see the Dead Sea to the right. And there, just about in the center of the picture, is where Jerusalem is located. As we back out, you get a good shot of the Red Sea down on the lower right part of the picture. And as we take a look down at the southern tip of the Sinai Peninsula, we will zoom in and we'll see the areas of Ras Nasrani, where it's very good scuba diving, I'm told by Ilan, is to be had by all. And as we work our way up the coast here, we'll see the area where Sharm el-Sheikh is located, and as we work up to the north end, we see where Eilat is located, the southernmost city in Israel.
This view is one of the most outstanding ones that we've had during our time up here. It's a pass over Saudi Arabia and the Persian Gulf. You get a good idea of the incredible views of clouds and water, and combined with the land, here you see some red sand dunes. The views have been incredible. We also passed over San Diego today and could see the very dramatic coastline there, and had some other nice passes over the eastern seaboard.
Here is a view of the Earth again, the Gibraltar area in the Mediterranean, as the view moves up the screen, with Spain on the left side and Morocco on the right side of the view.
Flying over right now Egypt, passing to the Red Sea, and on the top left is the Sinai Peninsula. You can see some clouds overhead. Just coming into view are some contrails from jet aircraft. It's just been full of beautiful sights up here on STS-107, and the views out the window just don't stop being really, really great. Here we are continuing. Jordan will be on the left and Saudi Arabia to the right.
And here's the back side of the orbiter, looking at Africa, at the Tagana Desert. And here in a minute we'll come to Lake Chad. This is Lake Chad under the back of the orbiter.
Here's Mount Vesuvius up close, and we'll move back so that you get an idea of how hard it is to pick out individual things. The planet is understandably very large. They've also seen some incredible views of the South Pacific. That's the tail of the orbiter, and there's a coral atoll in the middle of the Pacific. And again, we'll zoom out so that you can get an idea. There's that island in the vast ocean on our blue planet.
We start off showing you an orbital sunrise from the shuttle. What happens in about an hour on the Earth happens as quickly as you're going to see it. This is a view out the back window when we're flying Payload Bay to the Earth. Orbiter at night is a very pale blue, but rapidly it'll become kind of reddish, turning to gold, and even brighter gold. And then the orbiter becomes quite white. So we're going 17,500 miles an hour, and it's a beautiful sight, and we get to see that sunset and sunrise every 45 minutes. This is from this morning, and the blue shift getting to work. We sleep in sleep stations, which are bunk stacked 4 high. This is Mike and his. There's 1 below and 2 above. To the right are some clothing lockers, and to the left are some checklists and saliva collection kits. First thing we do for part of our biology set of experiments is record how we slept. And so that's what Mike doing, is filling out a paper log. He's also got a saliva collection kit in his hand. Then, of course, it's time to get up and go to work, and looks like Mike was dressed to work from the start. Nice thing about microgravity is you can sleep in your clothes and they don't get wrinkled. The middeck was pretty crowded this morning. We actually had all 7 crew members while we're doing our post-sleep activities and some payload ops at the same time.
Here is KC, not too long after we have, the redshift has woken up, going through the execute package. We use her excellent organizing skills to help get that stuff put together. We're at the aft panel. You can see some of the portable computers that we've got there on the right. And then we'll take a look at the front instrument panel. As we take a look in the forward part of the orbiter, you can see the pilot seat where Willy, McCool sits. And you see the forward instrument panel. The books from right to left are where we keep our daily execute package, our Earth odds info, and info for passing down items between the shifts. You can see KC here going from the flight deck down into the middeck, where we'll show you around a few of the things in the middeck with some of the day-to-day living things that we do down there. Right now, KC is lining up at the galley. You see the foot loops all over the floor there. It helps us kind of keep in place and keep us from moving around anywhere while we're down there. Keep us stationed there at the galley where KC is. She's still in a drink bag. And here we show you what personal hygiene kit looks like. This is kind of a shaving kit where we've got comb and shampoo, toothbrush, toothpaste. There's our shampoo coming out. Razor blades and various items in the Ziploc bag, and the ever necessary deodorant for the commander, and a razor and shaving cream there on the top flap. Here KC is showing us one of the food trays. These food trays have got 3 meals per tray for 4 people. So this is the red shift meal tray that KC has gotten out. And our undying appreciation goes to the folks who pack and manifest all the food for us so that we have these great meals up here. You see how the tray is arranged and how you can see things are really packed in there, but you can see some really good stuff like cookies, and here KC's pulling out one of the breakfast items, granola with blueberries. Here KC is preparing breakfast at our galley. We have what is called a rehydration station. That's just a fancy way of saying that you're going to put some water into this dried food and get the moisture back into it again. We've got these vacuum-packed plastic bags that the food is sealed in. This looks like she's got some granola with blueberries here that she's preparing for breakfast. Once we let the water soak back into the food for 5 to 10 minutes, then you can cut the package open with a pair of scissors and then eat it with a spoon usually. Now here we have the red shift and the blue shift all on the middeck during our handover before the blue shift goes off duty and the red shift starts their day. And what we do is we try and pass on what we've learned from the previous shift and what the status of the various payloads is. You can see just to the right of the picture is the hatch for the airlock, and certainly another important roll of gray tape. You can see right here on the left side of the middeck, we've got the galley. We've got the printer there where we print out all our messages that get sent up to us from the ground. And then behind this door, we have the WCS, otherwise known as the bathroom, because this is where we go for our daily hygiene. And you can see there the WCS with towels hanging out from the door, and the different cabinets that we have for tissues and different things like that. And there's the side hatch that I'm sitting in. Now, KC is going to go from the middeck back to the space hab, and she goes down the tunnel, and as she approaches the space hab, magically turns into Laurel as she comes out of the tunnel into the space hab to prepare for another arms run, which is an advanced respiratory monitoring system. She's getting on the cycloergometer there to do some tests with that payload. Since we're in 0G, you have to use a seat belt to keep you onto the seat there. Otherwise, it would be very difficult to pedal the bicycle. Also, while some folks do the arms experiments, they listen to a compact disc player. Here Laurel is getting her set up, and it's very interesting the gyroscopic effect that you get out of the compact disc player while it's spinning and you let it go and float in space. Here in the module you can see how things are laid out. We've kind of got a stowage area over here, and we wanted to show you our space iron. This is where Laurel laid out her shirt in preparation for the big press conference that we were going to have. And so that's how you straighten things out here in space. Here we are traveling from the airlock of the orbiter through the tunnel into the space hab module, and you can see Ilan here doing some space acrobatics in the module. And I think the cameraman did a few as well. Here comes the Superman entry of the astronaut from Israel, and Ilan has done such a fantastic job up here. It was a great thing to be able to give him a break and have some fun. You can see him doing a nice little pirouette, and then taking some time to have a snack that he's brought up. And you can see how the fact that we're in microgravity with things floating like they do make eating a whole different experience. And then here I am, once we've gotten through with the handover, up on the flight deck, loading a maneuver. During this flight, we have in excess of 250 maneuvers that we're doing for the various payloads. And our hat is off to Andy Lawich and his team. He's our pointer who's come up with the attitude timeline for our flight. And he and the FAO Terry Schneider and their team have just done a fantastic job coordinating all the different payload activities and the attitude requirements and such. Here's Dave having the last snack on the middeck before he gets ready for bed. And you can see the scissors, and he's having some dried pears for his snack. Additionally, one of the things that we have to do is to change out the what these are called lithium hydroxide canisters, and what these do is they remove carbon dioxide from the atmosphere. So we have kind of a closed environment here. We've got fans that move the air around, and every day Willy takes these canisters and changes them out with the previous day's canisters so that we can make sure that we keep the air in here at a nice breathable level for everybody. This location is in the middeck floor where the LIO canisters are located, and we turn off the cabin fan to stop the airflow, swap out the cans, make sure that the doors are good and locked, and then we turn the cabin fan back on to start the air circulation again. And one of the things we get to do that's very enjoyable is look out the window. Here's a beautiful view of the Earth as we come and make landfall over the continent of Africa in the vicinity of Morocco. You can see the Atlas Mountains there about the middle of the picture. And as we coast on past those, you see the beautiful desert scenes that we get from northern Africa and the Sahara area. And we'd like to thank you all very much for all the support that we've gotten and all your interest in the flight and all the great work from the folks on the ground. And this will conclude the crew choice of STS-107 for today.